Hello everyone, welcome to the next video of C programming. In this video, we'll learn a new concept of function that is known as function recursion. We'll understand the concept. Also, we'll write down some example so that you can understand how to start with function recursion. Okay. So function recursion means what? Function recursion means something you are defining in terms of itself. Okay, or in general a function which calls itself is known as function recursion. For example, suppose I am writing a main function. Inside this I am writing printf I, then I am writing main. Okay, so what I am doing here, I am calling the main function inside the same main function. This is known as a function recursion. Okay, so another objective of function recursion is you are breaking down the entire problem into smaller sub problems of the similar type. Okay. Now let us write down one example through which we will try to understand what do we mean by recursion. So one program we will write down factorial of a number using recursion. Okay. So what? Let us do one thing. You write the program without using recursion but using function, and then we'll convert the program into function recursion so that you can find the difference between writing a program without recursion and using recursion. There is another concept that if you will write the function definition before the main function, then function prototype is not required. Like suppose I'm writing int factorial integer number, and I'll define the function body before the main function, but I'll call the function inside the main function. Okay. Now here I'm expecting a result in the main function. So I'll write down result equal to factorial number. Okay. And after that I am printing the result. So first factorial percentage D is number and second one is your result. Okay. Now what I am doing here, I am calling the factorial function here. Previously we are writing the prototype above the main function and the function definition after the main function. But one more concept is also there, that you can define the function body before the main function. And in this case, function prototype is not required. Okay. Now how to find the factorial of a number? Already you have written this particular program. So we'll write on while number is greater than 1. Okay. So we'll initialize here. Let us write fact equal to 1, fact equal to fact into number, and then number minus minus. Okay. So that means till the number is greater than 1, where we can write also greater than equal to 1, not an issue. But if you write greater than 1, that is also fine. After that, you will return this fact. Okay. So fact is initialized to 1. If I'll take the example of 4, then 1 into 4, the result will be 4. After the number will be minus minus 3. So 4 into 3, then into 2. So that means every time I am multiplying the value, again I am decrementing. That means I am dependent on the lower value of this number. Okay. So let us check. Compile and execute. There is no warning and error. So if I write 5, so the output will come factorial of 5 is 120. Okay. So this is without recursion we have done. Now using recursion, how I'll do? First of all, we will not make any kind of changes in the main function. This will be completely similar whenever you are writing without using recursion. The only difference is you will not use the concept of loop in case of function recursion. Okay. So whenever I am calling the function factorial, it will come here. Okay. Now I am writing here if number is equal to 0 or number equal to 1. Okay. In any case, either the number is 0 or the number is 1. What is my factorial? I will return 1. Else I'll write down the program. Okay. So that means the base case you have to write down. This is known as your base case. Okay. That if I'll enter 0 or 1, whatever, it will return 1. Or my program will stop whenever my number will become 1. Okay. Otherwise, what I am doing here. Okay. I am writing fact equal to number into factorial of number minus 1. Means what? What is the meaning of this statement? The statement is, suppose I am entering the value as 5. I want to find the factorial of 5. So by using recursion, I am trying to say कि 5 into factorial of 4. I don't know what is factorial of 4. You find it again, but I know 5 into factorial of 4. So this factorial of 4 will calculate like 4 into factorial of 3. Okay. This factorial of 3 will calculate 3 into factorial of 2. This will calculate 2 into factorial of 1. Okay. This is what the idea while calling the function by using recursion. Okay. But internally, how it is working, that we'll see in details. Clear? Now finally, the result will be present in which variable? Fact. So that I need to keep inside the else. Okay. So that means function recursion means I am replacing the concept of loop through if and else. Okay. And I am just keeping a number or value. I am calling the same function, whatever the name I have given, with a new value. Okay. So let us first compile and execute. We'll see the output, then we'll understand the working principle of this particular example. I'll write on 5. Now see, the same output is coming. 5 into 5 is 120. Okay. So if this is known as your base case, this can be told as a recursive case. Okay. Because this particular section will execute repeatedly. Done. So let us understand in the background why actually or how it is being executed. So in the main function, I'm entering the number. I'm passing through the function called factorial. And in return, I'm expecting the result. Okay. Wherever the function will be called, the definition will be executed and then this section of code will execute. Okay. So let us try to understand with some values. Okay. So step by step, we'll try to understand. First of all, we have come to the main function. I'm calling result equal to factorial of 5. Okay. And after that, I am printing a result. Now, once this function will be called, the body will execute and which will catch the value 5. So the if condition will be false because number, either the number will be 0 or 1, then only it will return 1. Otherwise, it will come to the else. So now the else part will execute. So fact equal to 5 into factorial of 4. Okay. And here I am writing return fact. Okay. Now what will happen? Whenever this factorial of 4 will be called, many programmers they think the same code is executing, means it is calling to itself. Yes, it is calling to itself, but the same body will never execute. Another body will execute, which will catch a new value 4. Okay. Here also the if condition will not execute, the else one will execute. Why? Because the number is not 0 or 1. So it will come to else. So it will become fact equal to 4 into factorial of number minus 1, 3. Again, this is return fact. Okay. Now the next one. Whenever this factorial of 3 will be called, again another body will be executed with 3 coming to else. Again, fact equal to 3 into factorial of 2. Okay. And then return fact. I am just rewriting the same code again and again so that you can understand whenever you're writing the recursion program, it doesn't mean the same body will execute. It will call the same function, but a different body will execute. Okay. Now you're calling factorial of 2. So again, one more time, the body will write down integer factorial of 2. Okay. So again, the number is not 0 or 1. So the else block will execute. So it will become fact equal to 2 into factorial of 1. Okay. Then return fact. Now whenever this factorial of 1 will be called, the same body will execute factorial of 1. But in this case, my number is right now 1. So the if condition will be true. So what it will do? It will return 1. Okay. Now whenever the return statement will execute, the return will be done. What you have understood? The value will be returned to that particular function who has called it. So who called this one? Now this factorial of 1 has called. So this entire statement will become 1. Okay. Now 2 into 1, the result will be 2. Return fact, that means return 2. To whom it will return? Anyone who has called. Who has called? Now this factorial of 2 function has called this one. So 2 will be returned to this particular function call. So it will become 2. 3 into 2 will become 6. Return 6. To whom it will return? It will return in the reverse order to which function call it has called. So factorial of 3 has called. So it will become 6. 4 into 6 will become 24. So return 24. To whom it will return? Now factorial of 4 who has called it, it will return the value to that function 24. 24 into 5, 120, return 120. Whom it will return? Anyone who has called. So I have called this function from the main function. So 120 will be returned to this one. So 120. 120 will be assigned to the result variable. And finally, I am printing 120. Okay. So that means here in function recursion, the order you are making the function call in the reverse order, the value will be returned. Okay. Now, if you understand what is data structure, then you will be very much sure the concept is known as a stack. Okay. So function recursion implements the data structure stack in the background. Okay. Now this is what the function recursion works. Now, this is your task. You have to solve all these 3 problems. Sum of digits of a number, sum of n natural numbers, and Fibonacci series up to nth number. Okay. So through this video, what we have tried to learn the important concept of recursion through hands-on example. And also, we have discussed the working principle or the background details of the function recursion, how it works, how it calls, and how it returns the value. Okay. Now it is your task. You have to understand the code and you have to try the rest of the programs. Okay. So thank you everyone for watching this video.